Okay, so we can start now, and today we learn something about ROBBO education materials and about ROBBO education materials online. So I can screen share my share for you. I can click on this button. I use program BlueJeans for these options. And now you see my desktop, and now you can see a presentation. So, presentation of the ROBBO Online tour. We speak about ROBBO software, we speak about ROBBO Junior, we speak about ROBBO Scratch, about Tinkercad, about Minecraft and Unity, and all of this thing, and this is our online program. So, first of all, we ROBBO company, and of course we teach kids about some type of robots, about what is this robotics, and of course if we speak about robotics, we speak about many things, and if we wanna see these things, we can see these slides. So, and you can see robotics, how we can teach robotics for kids. First of all, if you have smallest kids, you use Robot Junior. Robot Junior, this is a special program for programming. So if you have not smallest kids, but just small kids, you can teach 3D modeling, circuit design, and programming. If you combine these three things together, we can create own robotics, because with 3D modeling we can create the body of robot. You can see this body. If you use circuit design, you can create a brain of robot. And if you use programming, you can create behavior of your robot. You can give some functions to your robot. So for 3D modeling, for small kids we use Tinkercad. For old kids we use FreeCAD, and we can use Tinkercad for 3D modeling and circuit design. So you can see this and this. But for programming, we use many programs. We can use Scratch or Robo Scratch, we can use Minecraft, and we can use, of course, Unity 3D. So Scratch our base program, this is our main program, and we can use this program, I think, often than others. So for teaching, we use special educational materials. So, for example, every lesson which we can conduct, there are free document. This is minimum free document, but online lesson have 4 document. So this is document methodical recommendations, technological map, workbook, and presentation. So I think first of all we can see these methodical materials, and if you click on online curriculum, you can see the topics, of course, introduction, 3D, and others, and you can see the documents. So if you click on methodological recommendation, of course you can see guidelines, and this is guideline for teacher. Teacher can see all materials in these guidelines, and with these guidelines teacher can conduct lesson. So the second important document, this is presentation. When teacher use methodical recommendation, with this recommendation you can see slides, slides number 1, slide number 2, and the other slides. So in presentation you can see these slides, and you can show these slides for your kids, as I show my slides to you today, for example. And of course kids can see these slides, and they can understand more and more with these visual things. So, and this is 2 documents. The next documents is workbook, so you can send workbook to your kids, and inside this workbook you have exercises for kids, and of course kids can use this exercise for classwork or maybe for homework. And the last document, this is technological map. So you can click on technological map, and you can see here some thing like road map or flow chart. So you can see objectives here, and you can see structure and content of the lesson, forms and content of educational activity. And of course, if you are beginner and if you do not conduct any lesson, you can use this technological map, and after you read this technological map, you can understand what you're gonna do, what you must to do, and it's important document for teachers and for the educational structure. So this is structure of our curriculum. So in every lesson you have 4 documents, and you can use these 4 documents for teaching students. So I think we can continue, and we back to the previous slide. So, and we start with 3D modeling. So now I show you all this program. I show you how you can use this program and what kind of knowledge this program can give to kids. And after that, you can ask some questions to me, and I of course can answer to these questions. So I think we can start. First of all, 3D modeling. So 3D modeling, we need to create the body of robot. We use some kind of program. We use Tinkercad for online modeling and for the smallest kids, and we use FreeCAD. This is engineering 3D modeling for the oldest kids. Of course, we use 3D modeling with equipment, and with our, you can see on this slide, our printer, 3D printer ROBBO Mini. But you can use 3D modeling with printer or without printer if you use online 3D modeling. You can create some type of mechanism, and you can print this mechanism. I can show you some type of slides. For example, this slide from our first lesson in 3D model program, and you can see a special design of this slide. So this is picture, this is definition, and of course definition in green frame, and you can read what is the 3D modeling. So this word means 3-dimensional, and 3D modeling is the process of creation of a 3-dimensional object model. And you can see next slide. So all definition have the same design. And where we can use 3D modeling. So this is the next slide from our first lesson of 3D modeling, and you can see 3D modeling application in computer games development, of course, as one of 3D visualization stage. For example, if you wanted to buy flat, maybe house, and this house so far away from you, you can use 3D modeling visualization, and you can walk in this house to make a decision. You wanna buy this flat or house, or you not wanna buy. So this is one of the examples. The next example, in prepare samples for 3D printing. So if you use 3D printer, of course you can prepare some type of examples, and of course for prototyping of products. So if you want to create some interesting thing, but you need, for example, factory to create the prototype, you can use 3D printer to creation prototype, and if prototype will be good, you after that can use factory for printing this prototype. So, and what kind of application we use for 3D modeling? This is 3D design Tinkercad. So now in my screen you see Tinkercad. By right mouse button I can rotate this work plane. Of course I can use a simple block here, for example box and cylinder, And I can use some actions here. So I can group these shapes, I can ungroup these shapes, maybe align, and the other interesting things. So let's create some simple thing. For example, I want to create a bridge. So I can use this box. I can make different form of this box. I can use the next type of box. So I can create something like this. The next thing, I can duplicate, of course, this thing. I can duplicate by Ctrl D. Then I can make this bridge bigger. After that, I can click on all these things and make group of these shapes. After that, I can copy and paste these things, this shape. I can change my switch of view, and I can align all of these shapes. I can switch to perspective view. So after that, I can use new box and create some kind of the protection device here. Of course, I can copy and paste. I can change snap grid. I can copy and paste again. Copy and paste here. And of course, I must align these things. For align, I use not perspective view. So now I create top of this bridge. So I think we can make this thing longer. This is the wooden bridge, and we do not need the super accuracy. So you can change the size of this thing. For example, of this cylinder, maybe 2 and 2 here. So now we create top of this bridge. 2 millimeters here, 2 millimeters here. After that, I can copy and paste this top here. Okay, make the orthographic view. So excellent. After that, I need create the low, the bottom of this bridge. So I need use snap grid by 1 millimeters because it's more comfortable for me. I can rotate, of course, my shapes. Something like this. So I can group this bottom of bridge. I can pass this bottom of bridge here. Maybe in 0.5 millimeters. Snap grid, yes, I think it will be enough. So after that, I can copy and paste. I can make from this one form, copy and paste, move here. I can mirror this thing, and of course we use wooden bridge. And if you want to create the illusion of wooden, we can use special instrument of holes. So we can cut hole from the solid surfaces. Now I can duplicate this thing. Oh no, sorry. Now I can duplicate this thing, and now I can create illusion of wooden bridge. So after that I can make one form from all these forms, and our wooden bridge is ready. And after that you can use this wooden bridge in any application, for example in games, or you can print this application, this bridge. Of course you can export your bridge in file and use this bridge in anywhere. And you can see in 5 or maybe 7 minutes I can create the simple form. And of course after education in 3D modeling, your kids can do the same things so fast. So this is the first what we make. We create 3D models for printing, for games, for anything, and we use Tinkercad for this purpose. So, and this is 3D modeling. So the next one, circuit design. We can back to this slide, and you can see we use robotics 3D modeling, we use Tinkercad and create body of robot, or maybe any application, any form what you want. So the next one, you can use robotics circuit design. We go to Tinkercad and we create the brain of robot. So circuit design, I can delete all this thing here. So I create new code now, new circuit design now, of course, create new circuit. And in offline lesson we use the Arduino microcontroller. We use the real LEDs, we use real potentiometer, we use real resistor, push button, capacitor and the other things. But in online lesson, of course, we must use the simulation of all this thing, and for simulation we use this circuitry program. And in this circuitry program you can use Arduino, of course, and you can use breadboard. So Arduino, this is microcontroller, and we can use this microcontroller to control the circuit which we can create on this breadboard. So first of all, we can use 5 volts by plus and ground by minus. We can change the color of these wires. For example, ground, we can use the black. For 5 volts we use red color. And for example, I can create now traffic lights with LEDs. So I can use LED 1, LED 2 and LED 3. So you can see cathode and anode. You know, LED can use electricity in only one direction. We can change the color of these LEDs. For example, this may be a red LED, this may be a yellow LED, and this may be green LED. After that, we must use resistor to protect our LEDs. So I can use resistor here. And after that I use short legs, and from the short legs I use wire to this resistor. Long legs I use to create a signal which goes to these LEDs. For example, red LED is the third button, third pin, so I can change color to the orange, for example. If I use yellow LED, I use yellow button, yellow wire, and if I use green, I can use, for example, 6 pins, and I use green color of wire. So, and after that we can program our circuit. So let's try to code. We can use code here, and we can code by the blocks, or we can code by the text. So you can use blocks and text, or if you want, you can use text. And of course, program ask us, are you sure? Not, of course I'm not sure. I can use blocks because it's faster than use text. So now I want to create program for traffic light. So how can I create this program? I use the output, and I use set pin. We have pin 3 by red color, we have pin 5 by yellow color, and we use pin 6 by green color. So I can duplicate this block, and high it's mean we use electricity and we use signal. Low, we do not use signal. Of course, LED is on by high signal and off by low signal. So for example, I use high. After that I can wait maybe 3 seconds. After that I can low these LEDs, and I can high yellow. Yellow, this is the shortest light, and I can wait 1 second. After that I can use low signal, and the last one, green signal, I can use high here, and green it's maybe 4 seconds, and after that I can use low signal here. So we can start simulation now, and you can see red, after red yellow, after yellow green. So we create traffic light, but we have problem from the this signal. We immediately go to the red signal. So this means we need to stop simulator, and we must create duplicate the yellow signal again, and after green signal we must create yellow signal again. So, and now I start simulation, and you can see a red one, yellow one, green one. After green one we go to the yellow one, and after that we go to the red one. So this is the easiest way how we can teach circuitry design with kids, because in online lesson kids often do not have Arduino microcontroller, or they do not have a breadboard or any materials, and of course they want to learn something on the circuitry design, and this is the good way how you can show circuitry design. So, and we go back to our presentation. So you can see Robotics, go to the circuit design, and you use Tinkercad for the both of this program, and we can create body and brain. And after that, so we use Tinkercad, and after that we go to programming. So programming, this is the biggest path of the robotics, and we use for programming many programs and many software. And of course we can start, for example, from scratch. Scratch, this is our basic program, and this program we use to create basic programs, and we use this program for teaching for kids algorithms. So I use Scratch. This is offline program, and I can change language this program, of course, in English. After that, I can create new file. So what we have in Scratch? We have the output window is here on center. Input window and output window is here. You can see stage, and in this stage you have special sprite. Sprite can make some actions, and we can use blocks from the left side to create programs here. So, okay, what kind of program we can create now? So I can create some type of controller. I can delete the sprite, and I can choose new sprite. Of course, you can choose any one of the sprites, and for example, I can use bear walking sprite. So you can see my new sprite, and I can program this sprite. My sprite have some type of costumes for animation, 1, 2, 3, 4, 5, 6, 7, 8 costume, and I can program animation. I can program anything in this sprite. So what I can create? I can create backdrop, and in backdrop I can use, for example, blue sky. I can put my bear on this blue sky, and I click on this bear, and I must create program. So I make big program. So when green flag clicks, our program is beginning. So you can click on this green flag, it means go, and after that all program below this green flag is running. So what program I want to create? I create program where bear will be walking. So I use looks block, and I use block next costume. When I use this block, this bear can change animation. After that, I can use block forever. This is forever cycle, and when we use forever cycle and block next costume, bear must change costume forever. But if I click on this button, you can see bear is change animation so fast. That means we can use wait block and use, for example, 0.2 second for this bear, and now you can see bear walking. But after we can go this program, bear is walking in one place. So we can use block motion, and we can move 10 steps with next costume. After that, you can see bear go 10 steps and change costume and go outside of the stage. Oh no. So we can back this bear because we have special block if on edge bounce. So now we can run this bear, and you can see after bouncing, bear go upside down. So you can ban rotation of this bear by left-right option here, and now you can see bear go right and bear go left. So what this means? You can use Scratch to creation algorithms. Why we use Scratch, and what is this program means for us? This is the most important program because if kids wanna study programming, they have two problems. First problems, this is problems with algorithm. The second problem is problem with syntax. These two problems, it's too difficult for kids. But if you use blocks, you do not use some type of syntax, because program go from top to bottom, and kids can learning algorithm. And after they learning algorithms, after they understand how programming is working, after that they can go to the normal programming language, not visual. For example, C++, or maybe C#, Python, or the other programming language. So, and the next reason why we use Scratch, we have not only programming things here. We have some type of equipment. We have Robbo platform, we have Robbo lab, we have Otto. This is the dancing robot, and we have Arduino micro scheme, and we have special blocks here, and we can connect equipment to Robbo Scratch. And I think it's the good reason why we can use Robbo Scratch. And of course, Robbo Scratch, this is open source program, and you can go to the MIT site, and you can see many type of program which which was created by kids, by adults, and by anyone. So this is the Scratch, and this is the basic software for our education. So, and of course, after Scratch, I wanna show you Robot Junior for the smallest. Sometimes kids go to your classroom, and when kids go to your classroom, so I can close Scratch, and sometimes they cannot read, and sometimes for these kids Scratch it's too difficult program, but these kids wanna create some things in programming, and if you have this type of kids, of course you can use Robot Junior for these kids. You can use Robot Junior from 5 years old kids. So Robot Juniors, this is the really simple program, looks like this, and you can create new project by this plus, and here you can really simple interface with the icons without readings. So any icons have some function, and you can of course delete your character and create new character. You can choose anyone, for example this fish, and you can create of course background, any background which you want, for example under the sea, and you can program this fish like you want. So you can use green flag for your programming, you can use move blocks, you can use move up block, you can use maybe some kind of looks block, for example high, and after you create this simple program, you can click on this green flag, and fish go forward, then go up, and they say hi. So, and you cannot make some mistake in this program, because this program for kids, and you can create any program here. What you can create in Robot Junior? You can create the tail, cartoon, or some type of animation. So, for example, we have two characters, and this character fish and maybe turtle. So turtle is here, fish is here, and turtle, this fish go forward by one cell, and up by 2 cells, say hi, and after that fish can send message to the turtle. Turtle can receive this message, and after turtle receive this message, this turtle must say hi, maybe how are you. So, and when we start program, you can see fish go, say hi, and only after this fish say hi, turtle say hi and ask how are you. So after that, this turtle can send signal to this fish. This may be a red signal, and the fish can receive this signal and say fine. Sorry, fine. And after that, this fish can make some action. Maybe this fish can make then grow up maybe and disappeared. So let's start program. Hi, how are you? Fine. Boom. So and you can create animation. You can create cartoons and details. For 5 years old kids, it's really important because they go to the classrooms not for programming maybe. They wanna learning something new. And if you try to explain all these things like programming things, it may be difficult for kids. And of course, you must create some story. Maybe in castles in the imaginary country. We have the characters and we have the interesting backgrounds, and we create some type of tales, and kids wanna be the authors of these tales, and they by themselves create some kind of interesting world, interesting environment, and they create tales. And for these purposes, this type of program, it's really good because in this really simple program you can use the icons, and you can create anything. So, and this is Junior for kids. So let's go to the next path, and the next path is the Minecraft. Why we use Minecraft? So you can see in our third slide programming, we can use Scratch, we can use Junior, and the last we need to use Minecraft and Unity 3D. So this is not main program. This is a program for additional education, in game, and this education in creative programming, because we can teach programming in many ways, and Minecraft, this is one of these ways. So what we can do in Minecraft? In Minecraft we create new world. We use game mode creative, and we can use super flat world. We create new world, and inside Minecraft we use special mod. This mod calls is computer craft edu. We can use this turtle, and we can use turtle remote control. We can use remote control for this turtle, and we can use beginners mining turtle here. After that we can use right mouse button, and now you can see the four options. This is remote options, inventory, customize, and programming. In remote options you can use special blocks to rotate and moving this turtle. In inventory option you can add some kind of game item in this turtle. In customize mode you can change color of your turtle. And in program mode you can program this turtle like you want. So let's program this turtle. I show you the simple program for this turtle, and I go to program here, and I wanna make the field of flowers. So I use inventory, I use decoration block. After that I wanna choose some kind of flower, for example blue orchid. I can put this blue orchid inside inventory. After that I go to program. I can type name of this program, maybe flower. And after that I can program. I have two type of editors. I have visual editor and code editor. Code editor, this is the Lua engine, and you can use code editor here. And visual editor, this is the same language, but you can use just these blocks. So how I can create the program? I can use button move up. After move up I can use cycle. Maybe I think use 6 times do, and I can place down thing from my inventory, and after that I move forward. So, and here I can use end button. So after that I go to remote and run program. So, and you can see this turtle can place this flower on the ground, and 1, 2, 3, 4, 5, 6 flower, I think. 4, 5, 6 flowers. So all what I want. I can destroy my turtle, and I can use this turtle again. I can go to the inventory, make this turtle blue orchid here, and now I can make this program more difficult. So I wanna place this flower by line. So how I can create this program? So I wanna I wanna place this flower by columns and by lines. So this is my columns. I can use maybe 10 columns. So and after that I need lines, maybe 6 lines, and do, of course. After that I can use place down, move forward, and after I end one line I wanna turn right, but I have some problem. If I turn right here, so this is the end, and now I can place down, turn right, go forward, turn right, and then I create the next line. I need turn left, so I need some kind of variable which can change by the line, and in this program you can use variable, for example x equal by true, and you can use this type of code. If x equal true, then you place and go right, and after that you must x equal false, else you must place down, turn left, go forward, turn left, and x equals by true, and here and here. So let's try run this program. So we can place one line, go right, place next line, go left, and place next line. And the turtle will place items in this line until the moment then flowers will end. flowers will end. So now turtle is stopped, and you can see no items to place. So if you have some mistake, of course turtle can say about this. And why we use Minecraft? Because Minecraft is a really popular game, and many of kids know about this game, and sometimes kids go to the classrooms for playing Minecraft, but they see the program inside Minecraft, and you can change anything in this world by this turtle, and it may be really interesting for kids and for learning programming. And of course Minecraft is a really good program to make online lesson, and I think this is most important thing in Minecraft. You can create your own online lesson in Minecraft. So I save and quiet and closed Minecraft, and we look on Junior, Tinkercad, Scratch, Minecraft, and the last thing, this is Unity 3D. So Unity 3D, this is a program for old, not for old, not for small kids. I think Unity can start from 11, maybe 12 years old. And in Unity we can create anything. So we use Unity for simulation and creation games. In Unity you can use your own 3D models. In Unity you can use your programming skills, and in Unity you can create anything. So now I show you video from Unity, from our final project which we create in Unity engine. So this project can create with 8 lessons, and after 8 lessons kids create some type of game. So this is the simple game, and you can use interface, and you can use your fly ship, I don't know, spaceship, and of course you have some type of music here. I don't you can see zero volume because so this is the options. After you can click back, then you can click begin, and with Unity of course we can use, for example, lab, and if you don't want to use lab, you can use keyboard. Of course you can use Unity without equipment. So you can see the menu, you can see animation, so rotation of asteroid, you can see special effect, you can see stars, you can see asteroids, and you can see counter here. So asteroids is 1 now, and of course you can use your skills. When asteroid kill you, of course you must play this game again. Then you click begin, and you can use blaster, and when you use blaster you can destroy asteroid. And of course you have special effects with blaster. And you can see background is moving forward to you. So this is the special animation, and it looks like the plane go forward. So, and in Unity of course programming is difficult, but for smart kids and for the not young kids, it's the good way to create some type of game and create some simulation and many interesting things. So and that's all for today.